Welcome, friends, to 18.4, which is entitled The Lens Equations. We're going to be using the mirror equation that we did last chapter inside the realm of lenses. And so this equation should look familiar to you. 1 over the focal length is equal to 1 over the distance to the image plus 1 over the distance to the object. This equation works for lenses as well as mirrors. And the same magnification equation. Magnification is height of your image divided by height of your object equals also the negative distance to your image divided by the distance to your object. And just like with our mirrors, you have to watch out for the focal lengths. When we're dealing with lenses, when you've got a convex lens, that has a positive focal length. When you have a concave lens, that has a negative focal length. The distance to your image, again, that deals with virtual and real. Same rules apply, that if it's a virtual image, it's going to have a negative distance to your image. If it's a real image, it's going to have a positive distance to your image. I've got 2 examples I wanted to go through with you, just to kind of give you an example of this. It says an image formed by a convex lens. It says an object is placed 32 centimeters from a convex lens. That has a focal length of 8 centimeters. Where is the image? So this wants to know where. How tall is the image? What is the orientation? Orientation means upright or inverted. So we're going to go through it. So we'll first tackle the lens and mirror equation. 1 over f equals 1 over do plus 1 over di. The focal length is 8 centimeters. And since this is a convex lens, that means that that's positive. So we're good to go with just 1 over 8. The distance to my object is 32. The distance to my image is unknown. So if you want to, you could roll. I'm just going to make common denominators here. This is going to be 4 over 32. So 4 over 32 minus 1 over 32 is 3 over 32. So that means that my distance to my image is, you flip that, 32 over 3, which is 10 2/3. Well, we only got 2 significant figures, so we're talking 11 centimeters, all without the use of a calculator. You don't need calculators if you don't have to use them. Actually, it was a lot quicker for me to just do it right that. Oop. 11 centimeters. How tall is the image? Hi over ho equals negative di over do. Height of my image is what we're looking for. Height of my object is 3 centimeters. It's right here. Negative distance to my image, I'll go with the 10.7, and I'll round it later. And then distance to my object was 32. Here I might need to bust out my calculator. So I'm going to cross multiply and divide here. So I'm going to do 10.7 times 3. Now this is going to be negative, by the way. And then I divide by 32. It's like 1. The height of my image is negative 1. Negative 1. So, height, negative 1.0 centimeters. Upright or inverted? It's inverted because that negative. Since the height's negative, it's telling you it's upside down. The next one. It says an image formed by a convex. Well, I think I want to change it to concave because there wasn't an example here of a concave, just so you can kind of see the difference here. This is the exact same question, it looks like, but we're going to do it with a concave lens. So the only thing that changes is the focal length. So 1 over the focal length. The focal length becomes now -8. Distance to my object stays again 32. So I'll put that back to 4 over 32. So it's -4 over 32 minus 1 over 32, and that's -5 over 32 equals 1 over di. So you flip that, and the distance to your image, 32 over 5, which is 6 2/5, so 6.4 negative. So the distance to my image is -6.4 centimeters. That means it's virtual. If you go back to the last question says that since this is positive, that means that this is real. A real image because the distance is positive. I've got a negative distance, that's going to mean it's virtual. If it's how tall is this thing? Hi over ho equals -di over do. Height of my image, unknown. Height of my object, 3. Negative. Distance to my image, negative 6.4 over the distance to my object, which was 32. So pull out the calculator for this one. Cross multiply 6.4 times 3 divided by 32. 0.6. So the height of my image is 0.6 centimeters. And then what is the orientation? Since that's positive, it is upright. And you're always going to get images that are upright when you look through a concave lens. So when you go back to those examples from 18.3, you're going to see that all of the images, no matter where the object is going to be right side up. So this is just kind of another application. It's very similar to what we did in mirrors. Not much different.